We've all seen the images, right? Rivers swelling over their banks, towns underwater. But have you ever wondered what's actually happening scientifically to make a river do that? Well, in this explainer, we're going to dig into the science and unpack the powerful forces, both from nature and from us, that cause a flood.
So it really boils down to this big question. Are floods just something nature throws at us, or do our own actions actually make them worse? It's a classic case of physical geography clashing with human impact. And you'll see, the answer is a little more complicated than you might think.
Okay, first things first, let's get a really clear definition. At its most basic, a flood is pretty simple. Think of a river as a pipe. It can only handle so much water at once. When you force way too much water through too fast, what happens? It overflows. And that overflow, that's a flood. To really get this, we have to start with the planet itself. Long before we were building cities and roads, rivers still flooded. So let's look at the purely physical, natural factors that set the stage for it all.
The main trigger, and this won't be a surprise, is usually rain, and we're talking a lot of it. This could be a really intense short downpour, or it could be that steady, nagging rain that just goes on for days and days. Either way, both can totally overwhelm a river system.
So what happens to all that rain when it hits the ground? Well, at first, the soil just soaks it up. But, just like a kitchen sponge, the ground can get completely saturated. Once it can't hold a single drop more, the water has nowhere left to go but to just run right across the surface, straight into the river. That's what we call surface runoff, and it's a huge piece of the flooding puzzle.
And this brings up a really crucial point. Not all ground is created equal. Take a look at this comparison. You've got permeable ground, think of a grassy field, which acts like a natural break, letting water soak in and slowing it down. But then you have impermeable ground, like hard, compacted dirt, which does the exact opposite. It's like a water slide, sending that rain rushing straight to the river.
And it goes even deeper than just the soil. The actual rock underneath plays a massive role. Permeable rocks, like limestone, are full of tiny holes. They act like these giant underground reservoirs, safely storing water away. But then you have hard, solid rock like granite. It's a total roadblock. It forces all that rainwater to stay right on the surface, which makes flash floods way more likely.
And there are a couple of other natural factors to think about. First is relief, which is just how steep the land is. A steep valley is basically a superhighway for rainwater. The other thing is drainage density. If an area has a whole bunch of little streams and creeks, it acts like a super efficient collection system, channeling all that water into the main river incredibly fast. Okay, so we've seen what nature does on its own. Now, let's add us to the mix. This is where we see how our own actions can take these natural processes and just turn up the volume, seriously amplifying the flood risk that's already there. And one of the biggest ways we do this is through urbanization. Every time we build a city, we're essentially paving over those amazing natural sponges we talked about. We replace the soft soil and forest floors with concrete, asphalt, and rooftops, all things that are completely impermeable. And here's what that looks like in action. In a natural area, rain falls and it soaks into the soil. Simple. But in a city, that same rain hits the pavement and is immediately funneled into storm drains. The end result? A much bigger, much faster pulse of water hitting the river all at once. It's not just cities either. Deforestation has a massive impact. Trees are incredible. Their leaves and branches act like a natural umbrella, catching a ton of rainfall, which slows it down and lets a lot of it just evaporate back into the air. When we clear those forests, we remove that protective canopy, and way more water hits the ground, way faster. So you've got all these different factors, both natural and human, all mixing together. How in the world do scientists measure and predict what's going to happen? Well, it turns out they have a really crucial tool for basically reading the river's story. And that tool is called a hydrograph. You can think of it like an EKG for a river. It shows us exactly how the river's flow responds after it rains. This is the key to turning all this theory into actual, predictable data. So what is it exactly? It's actually a pretty simple graph. It plots the rainfall over a period of time, usually as blue bars, and then it shows the river's flow, or what scientists call its discharge, as a line. By comparing the bars to the line, you can see the river's reaction almost in real time. Now, one of the most critical things we learned from a hydrograph is something called lag time. This is simply the delay between when the rain is falling the hardest and when the river reaches its highest point. And a short lag time
That's a huge red flag. It means water is getting into that river channel dangerously fast, signaling a very high risk of flooding. Another part of the graph you'll want to look at is the rising limb. That's the part of the line that's going up, showing how fast the river's discharge is increasing. If you see a really steep curve, that tells you that water is entering the river super quickly, which points to things we've talked about, like steep slopes or those hard urban surfaces. And this slide right here just puts it all together perfectly. I mean, just look at the difference. On the left, a forested valley gives you this slow, gentle curve. But on the right, the urbanized valley gives you a super fast, spiky, and frankly, dangerous response. You see that short lag time, that steep rising limb, and a much higher peak flow. This is the human impact, visualized as pure data. Okay, so we've got the science, we've seen the data, but so what? Why does any of this matter? Well, this knowledge is what allows us to go from just reacting to floods to actually proactively protecting our communities from them. By putting all of this together, the geology, the land use, the hydrographs for a specific river, scientists and city planners can literally map out which areas and which communities are most vulnerable to flooding. This isn't just an academic exercise. This is about saving lives and homes. And that really is the key takeaway here. This tool, the hydrograph, isn't just for looking back at what happened. It's the playbook for designing solutions for the future. Things like building better flood defenses, or even better, creating more parks and green spaces in our cities that can act like those natural sponges we paved over in the first place. Which kind of leaves us with one final big thought. We've seen how nature sets the stage and how our choices can dramatically change the outcome. So as our climate continues to change and our world becomes more urban, the real question isn't just about how we're going to control the water, but how we're going to choose to live with it. Thanks for tuning in.